This is lecture 14, example 2. So this is a example problem, assembly language, and it actually uses one of the instructions we were just talking about. Makes it handy. And so this is what we're doing here. What we have is we get sent a value in a register, and that value is a 2-digit BCD number, and what I'm going to do is double that number. So BCD is effectively decimal, and the idea here is that what I'm getting in this register, this is X10, what I'm getting here is 2 nibbles. This is the ones, and this is the tens. So it's not really known what's in this, these upper 6 nibbles or 3 bytes, but we know that the lower byte in X10 is a 2-digit BCD number. So for this problem, what we want to do in this thing is grind through it and double this thing. So the idea here is it's a very simple algorithm. And it's actually simple. It's harder to implement. It's just a pain in the butt. The idea here is I am just essentially going to double the rightmost digit, which is the ones digit, then I'm going to look at it. If it's 10 or greater, then I have to adjust the next digit upwards, and I do that by subtracting 10 from the current digit and then adding a 1 to the digit above it. So it's exactly like doing addition and just normal, like you did in 2nd and 3rd grade. It's just to add it, and you got a carry. So you have a carry to deal with in this problem, and when you have that carry, you have to deal with it accordingly in code. So it's not done for you. It's really interesting because some instruction sets do have the ability to work with nibbles, and particularly to help work with BCD numbers, but not in our instruction set. So we're going to give this a name. I'm going to call this 2x BCD. Looking good. Okay, so certainly going to have to init some stuff. And then I'm going to, what am I going to do next on this thing? I am going to kind of mask the value, and you see I need to make sure I'm only working with that part, and then I'm going to add them, and then I'm going to see if it's greater than 10. Result greater than 9. We'll say greater than 9. Probably not how I'm going to implement it, but if it's no, then we're good. We get to go on. But if it's greater than 9, I have to put it in one big box. Subtract 10 and add 1 to 10's digit. So I'm subtracting 1 from the current value. I'm subtracting 10 from the current value, and I'm incrementing the 10's digit by 1. And so at that point, I am ready to go on to the next thing. And so that's going to be, I'll say massage the 10's BCD. And then I'm going to, add it. Add 10's. And we'll say greater, result greater than, we'll just say 10. We'll say 9 again. And if it's a yes, we have to, I'll make it neater, subtract 10 from the 10's and add 1's to the hundreds. And then I think I will say, I'm going to say it, accumulate this thing, since we're going to have multiple values floating around there, and then we are done on this. So lots of stuff going on there. Not too bad, but it's going to make for a fairly long problem, but it's very doable. So let's go do it. So I'm going to switch over. Unfortunately, I'm going to switch over to the so I can type this thing out. It's just easier to type it, and I can it's neater, and I can tell you what I'm doing along the way. Okay, so here I am on the typewriter, going to type this thing. Gotta type this thing out. So I made a copy. I made a copy of my flowchart that we did in the other piece of paper, and now I think I'm ready to write this program out. So here goes nothing. Okay, so we gave it a name. We called it 2xBCD. Hopefully you can read that. And then I need to knit some stuff. So the stuff I need to knit for this is the final answer, which is an x10, which was called out by the problem. So I'm going to move x10 0. So I'm clearing an accumulator. Okay, so, and what else am I going to do in this thing is I am going to need to make a copy of a working copy of this data, because I'm going to have to mess it up. And then I know I'm going to need to do this, move x, we'll say x15, x0. Okay, so I cleared a register, so this is a carry. And you're going to see I'll need a carry coming out of that first digit. Okay, so I'm ready to do this. We'll also give it a fancy name. Do ones. And so I'm going to take x20, and I'm and x20 with x20. We'll just keep it x20, and I need to mask it. I don't know what's in that thing with this 0xf. Mask. This ending it with 0f clears everything except the lower nibble, and then I can work from that. Okay, so at that point I'm ready to add this thing, and I can just retain this, add x20. I can keep using x20, and so this is doubling. Let's say 2x1's digit. Okay, so I'm doubling these things. Okay, so I'm getting through this thing. Adjust my chair here, and then I'm going to use an instruction. I'm going to set if less than immediate x20. No, we'll say x5, x20, and we'll say if less than 0xa. Okay, so if it's less than 10, if it's less than 10, that's good. Okay, so, and that's what I want to do. So if I'm going to say branch not equal to I'll get this right, x5, x0. If it's essentially, if I'm branching if the thing is set. If it's not equal to 0, I'm branching, and I'll call this do tens. Jump if there was a carry. Okay, and that looks good. Okay, so this is the point. I'll come down here a couple of lines and say get rid of the line do. Get rid of the red lines. Okay, that's good. Okay, at this point I have to adjust this thing, so I have to subtract 10 from the result, because I know it's greater than, I know it's 10 or greater, so I'm subtract 10 from it. So this is going to be add immediate, and this is x20 minus 10. That works. I could use the subtract instruction, I just didn't. Next thing I need to do is I need to set the carry, and so I saved myself a register for the carry, and I'm going to add with the carries at 0 from this instruction up here. Add x15 x15, x15, 1. I'm going to add 1 to it. Okay, so it's at 0. I'm incrementing it. So this is going to be an increment carry. All right, and then it's going to drop down to this instruction. So in this instruction, we at this point we have the answer we're looking for in x20, but I kind of ruined it. So I need to work with x21. So here we are at x21. So what I'm going to do here is and I need to clear it, and immediate x21, and I need a different one. I'm working with the tens now. So this is 0x0, f0. I'm looking at that working at the tens nibble. Mask tens nibble. Okay, looking good. And then I can double it. Add x21, x21, x21. This is 2x tens digit, and then I'm gonna do the same thing as I did before, and I'm just gonna look up there and copy the code. In fact, I'm just gonna go copy it as is, changes I need to. It's a nice part about doing these online. Yeah, I lost it. Cut and paste, man. Cut and paste engineer. Okay, set if less than. I'm not interested in this. Set if less than. I'm keeping it in I'm keeping it. I didn't shift it over. It's already shifted over, and so this is going to be less than 0x100. Okay, so if it's less than that, life is good. I don't need to worry about it. Otherwise, I need to. We'll just call it done. Oops, that's why it didn't work. Somehow I got in other mode, so we'll come down here, home, done. There's my done. We'll worry about that later. Okay, so this is the port where we'll call it fix tens. Okay, because it got a carry out. And let's see if I did this right. Up above. No, I don't think I did it right. So at this point, before I do that check on this thing, what I need to do is add in the carry x. So this is x21, x21. Should have been looking at my flowchart. I'm doing this from memory. So the carry was in x15. Okay, so the carry is actually looking at this is wrong. And the carry is not a 1. It's actually 0x0. Well, I'll put a 0 there and a 0 in front of it. It's actually a 0. It's actually a 1 that's shifted over by 1 nibble. Okay, so that's x15. So before I double it, I need to make sure I'm doubling the right value. And so I'm doubling it from the after I add the. Okay, so and see if that's right. I'm questioning whether I need to double it. Questioning when I need to double it. I think I need to double it. I think I need to add the carry after I double it. So I doubled it, and then I add the carry. So that's right. Okay, that's all right. I got scared there for a second here. So this is the same idea, and if this thing makes it to this instruction right here, that means there was a carry, so I have to adjust it. So I'm going to add immediate x21, and what I'm going to subtract from it is minus 0x. Okay, 0, got to get this right, 0 a. A0. So I'm subtracting an A. Up here I subtracted A from it. Here I'm actually subtracting an A0, which is the appropriate value, and that should get me the right answer. And I'll go check this out to make sure it's right. So this is going to be subtract 10 from tens digit. Okay, and after that, I'm going to add immediate x21, and I have to add 0x100. So I'm adding a 1 to the hundreds digit. This is the same exact algorithm that I did up in the ones digit. Add okay, and then I think I'm done with that. And so before I'm completely done, I need to formulate the answer, which should be x. It's an x10. Add x10, x21, and x20, and this should get me the answer here. And we'll do a return on this thing. And I think I'm ready to test this. So actually, I'm going to put some test code in here. So this is going to be load immediate x20. X20? That's the cent value. X20. We'll put in 99. 0x99. It's a hex 99. Okay, so this should be 99 times 2 is 198. So if everything works out right, by the time I get to the end, there'll be 198 decimal in x10. So let's see if I did that. We'll step through it real fast here. Don't want to bore you with stepping through it. And looks like I stepped through it too fast, so we'll do it again. Okay, so let's see what we got in x10. Please, 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 please. x10 is a 1/8, and that doesn't seem right, but it could be 24. Okay, so that sucks. So why does that suck? Because we didn't fix that, that's why. Okay, so let's give that another shot. X10. That's 24. It still sucks. Okay, stepping through the debugger on this one again. So we got to get this right on this one. Okay, so that looks better. So we forgot to copy x20. We weren't doing anything. So we'll give it one more shot here. So apparently it's working now. I must have stepped through it too fast or something. I'm going to check it one more time. I didn't make any other changes to it. And so we'll step through this. And what it should end up with is, by the time I get to this jump instruction at the end, which is the return, it should have 198 in hex in x10, and that's what you see there. So that's right. So anyway, the moral of the story is I don't get this right the first time. Structure is always pretty good, but I always make an error somewhere, and it's to be expected. And certainly, when I'm grading these on a test or something like that, I don't catch this level of error. And when I'm grading these, it's mostly seriously, it's mostly getting the structure right. And as you can see, half the time I don't get the instructions right. It's not expected. You're expected to use the debugger on these things.